Welcome to the next installment of Upgrade the Toyotron. It's the day after Christmas, Boxing Day as it's known in Canada. It is now outside here at my place in Thailand, 35.8 degrees Celsius. That's mid-90s if my math is right. So it's just too frickin' hot to work on the bike outside. So I brought it up the freight elevator, and with inches to spare, it's here in my room, in my lovely air-conditioned space. Now, I don't have a lot of work room. There's the desk, my balcony and my coconut tree, the chair, and the bed, and that's all we've got. So today's job is, there's a few lined up. We've got to take the front fairing off to get at the internal wiring. First I want to understand how it all goes together, because it'll be on and off several times. One of the critical jobs is to disconnect or greatly reduce the sound on the speaker that beeps when you're indicating a turn. It's just insanely loud. Next thing we want to do is install a install a USB power supply that Abel gave me. Let's see if I can find that. It's designed to be wired into a 12-volt power system. 12 volts input, the magic happens inside the box, and you get two USB jacks coming out. The reason that's important is I need power to the tablet, which will become the dashboard, and I need power to the camera, which is my traffic cam, which is going to be mounted, hopefully, right under here. And that's part of what we're going to explore today also. So, next step is to get at the inside of the fairing and see where we can mount the USB power supply and figure out where that speaker is. I'll just give you an idea of what it sounds like. Hopefully it won't freak out the neighbors. Okay, that just doesn't work. Well, that was pretty painless. Several screws, a couple from the front, mostly from the back, holding the front fairing in place. A pair of wires to the signal light here, a pair of wires to the signal light here, and then one 3-pin clip for the headlights, high beam and low beam. Then inside the front of the bike is pretty plain. You can see the back of the ignition key, power, that's where the headlights plug in. There's the infamous horn, and take a look at that. That probably is not really what I want happening inside, clunking around, so I'll take care of that. So now I'm going to get to work. Start with the horn. Okay, the thing that I thought was the horn is in fact the horn, but it is not the blinker beeper, as my ears complained bitterly upon first test. But so I took the cover off the top of the dashboard, and I think it's this guy, which helpfully has a disconnect on it. So let's see if we disconnect it and if the beep goes away. Okay, good news, bad news. Good news is I disconnected the speaker and I didn't get any voltage on the blinker light. So I put a jumper on the connector, because if this is the speakers in series with the circuit instead of in parallel, this jumper would complete the circuit, faking out that the speaker's there. And I got 12 volts on the voltmeter, but it was a steady 12 volts, not like jumping up and down like you would expect. So I hooked up some wires and I put the blinker on, and this is what we get. It's a solid light, it's not blinking. So the speaker, in addition to making squeaky noises, contributes to the blinking function. So I got to figure out how to do that without building a 555 timer circuit. More investigation needed. So I pulled apart the speaker, and yes, there's a speaker circuit, probably a little amplifier, but there's a transistor and some resistors and some capacitors. So this is what we get the on-off blinky function. And there's our tiny little beast right there, the round little speaker, and it's soldered in with a couple of pins right there. Focus, you fack. So what I'm going to do is unsolder the speaker and try it. And if it blinks, we're good. If it doesn't blink, I may have to put a jumper across there again to complete a circuit if the speaker is in series with the active things that are going on rather than in parallel with it. So let's give that a shot. So in my hand I have the device of evil popped out, lickety split. Plug the little circuit board back in, and Viola, we have blinky and no soundy. So I'm gonna crush you and do some horrible things to you. Okay, problem number 1 solved. Number 2, installing the USB power. Okay, now the hunt is on for 12 volt power for the USB power pack, but I want it to be switched on and off with the key because I don't want 12 volt power to be constantly drained out of the bike powering the camera and the tablet if I'm parked somewhere for a short time or overnight or 2 or 3 days in the car park. So first thing I saw were these 2 obvious unused power connectors right here. Sadly, it appears that it's only getting 6 volts DC out here, which is a little marginal for converting to 5 volts out the USB. I'm not confident in that. And I think what's happening is this is coming out of the instrument panel. So there's power being consumed in here. Maybe there's an internal regulator for something that needs 5 or 6 volts inside, and then that is coming back out to here. I don't like the margin of error with that. So poking around a little more, I found these 2 guys. And if we look at the voltmeter, you probably can't see that in the shadow. Key on, 12 volts, key off, drain down to 0. So, this is my new best friend right here. Strangely, the plus side of the circuit, they're using black wires. The minus side of the circuit, they're using a red and a yellow-green. In low voltage DC, red is plus and black is ground. But I don't know what to expect, so now I need to make a clean splice into these wires, a detachable splice, just to keep everything nice and clean and non-permanent. So I got to get to work on that. Well, bugger, wouldn't you know it, I traced these connectors back, and it turns out that they attach to the switches for the brake handles, which in turn get connected to the brake lights. So even though we've got 12 volts flowing now, I pull the brake and we lose our power. I pull the brake and we lose our power. So that's not particularly good for keeping the tablet and the camera powered. So I got to go find another clean source of switch 12 volts. Okay, thwarted again. Subsequent investigation, I checked out this connector, which goes right into the key switch mechanism. You can actually see the, maybe you can't see, the bar there locks the steering column, and it's the main on-off switch for the whole bike. This is 60 volts running through here. This is full battery pack voltage. Scary, scary, scary. I cannot hook up the USB power to that because it will get very angry and let out all the magic smoke. So, I went to this connector, which is where the headlights connect to. And I said, all right, I don't mind riding around with my headlight on all the time, because what I intend to do is swap these out for LEDs very, very soon, because they take a hell of a lot less energy to run, and I don't want to have to take the whole front fender off to get at the connector to switch it out, even although somebody with very, very tiny hands might be able to reach up from underneath and get that. So that takes me back to the connector. There it is. I switch the headlight on, I get 12 volts. So this is the headlight right here. That's parking lights, I lose power. That's off, I lose power. So I've got to have full headlight on. And then I thought, oh crap, there's 3 wires. I went to the high beam, low beam switch. I switch to high beam, I lose power. I move the connector to the other pin, and I have 12 volts on the other pin. I switch back to low beam. I lose my 12 volts on that pin, and the 12 volts goes back to the other pin. So that's not going to work, because as I switch from high beam to low beam, as you do, I'm going to have and then not have 12 volts power. So I got to search for yet another solution. Also, while poking around inside, I was talking about fit and finish before, and I'm going to show you another example. The fender actually rubs right here against the front fork on both sides, and it's literally held in place with one bolt right here. You can see, oh, maybe you can't see, there's a number of other mounting holes provided, so this is like a stock fender from something else. And one bolt, we're going to get a lot of clinking and clanking. I'm going to see if I can do something about that. We saw this bracket before. There's simply no star lock washer on that. That's going to loosen up over time. You've got connectors going like this. You've got this, which is the hydraulic hose that goes to the front brake, is literally not attached to anything. This is the odometer cable, not attached to anything. So I'm going to have to buy a whole big old pack of zip ties and get everything snugged down inside here. That'll get rid of a lot of the rattles that I've been hearing. And it's so quiet, you can hear everything. Also underneath, I may get to that later, but where the side kickstand and the center kickstand go, it's just metal against metal. And so when you hit a bump, they just clang every time. So I'll probably put a nice piece of rubber in there to separate the metal to metal contact. And I continue my search for 12 volts. Okay, after a couple of hours of digging, I can safely say there is no switch 12 volts available inside the front dashboard area, which is a little troubling. So I'm investigating the rest of the power system, which is back here. The batteries are in a giant fiberglass box here that I added Velcro to this mat so it wouldn't blow away on the road. And then I took the seat out, and you can't see very well, hopefully it brightens up, but this is the motor controller, and then mounted on the back side of it is apparently the 12 volt converter, 60 volts to 12 volts. Now again, we have fit and finish issues. This plastic flappy thing which I'm assuming just keeps the water and dirt out, is completely unconnected at the top. There are two bolts here. The bolt to the upper left just fills up a hole. It actually mounts to nothing. The other bolt is the only thing holding this whole thing on. You can see it's not attached in any way at the bottom. And I can now finish pulling the packing foam that the rear shock absorbers had on them, as I couldn't reach up high enough up here from when the bike arrived. Oh, the plastic is actually right here, jammed into the coils of the spring on this side. I'm going to see if that's adjustable and shift that over a little bit. And it's probably supposed to be held by this little bracket, which doesn't even have a screw in it, and it's supposed to attach to this little doohickey right here with a hole in it. There's no screw. Oh boy. I gotta hand it to them, they tried, but clearly they are not up to the standards of mass production yet. Okay, more hunting. Just for fun, I thought I'd take a look at the controller. I'm hoping it's programmable or has some adjustable settings, because for me the throttle's a little bit grabby, and if I could smooth out the acceleration curve on it, that would be just awesome. So it's probably hard to see on the sticker, but we are the Wuxi Lingbo Electronic Technologies Company Limited. 60 volts. Serial number is apparently date code 2015-09-10, the 9th month, 10th day, or 9th day of the 10th month of 2015, number 772 that came off the line. I'll check around, see if I can find any data about this guy, but it's a big hunk of metal, nice heat sink, got the battery pack voltage coming in on the big red and green. We've got the motor output wires going here. We've got the Hall effect sensors from the DC brushless motor coming in here. I believe this is the throttle input. And that's about it. So, digging a little deeper, that's the backside of the DC to DC converter. So let's have a look and see what's up with that. Okay, here we have arrived at the heart of the matter. This is the power I'm trying to find. Focus, you fuck. Focus. Piece of crap. Okay, you're gonna have to trust me on this. Electric converter. The red line input 60 volts, the yellow line output 12 volts, the black line public end cathode, ban, red and yellow line reverse connection. So it does have reverse polarity protection, which is cool. It's unbranded, model number DC60-12, and that's pretty much what its job is to do. It's extremely light, even though it has a metal box, so I'm really concerned about loading this little boy down with the extra power burden that I'm going to be putting on it. The tablet can pull up to 2.1 amps if it's desperately in need of a charge. The camera, I think, is about an amp while it's charging off its USB, so that's 3 amps. There's no way this guy's going to be happy running the headlights on high beam with a blinker turned on and the entire dashboard and another 3 amps of draw. So I have got to find another one of these guys, 60 volts in, 12 volts out, or and then run that into the USB converter, or 60 volts in, 5 volts out with USB connectors. That's probably a little bit too much to ask for, so I'll just see what I can find on the market. And it looks like the bike's going to be here in my condo in pieces for a while. I'll have to go back to ride the gasoline bike for a while until I can get this thing rolling again. Okay, good news. AliExpress, 60 volt to 12 volt converter, waterproof, heat sink, bolt mount, 5 amps output. Should be plenty of headroom. Price $8.48 and $6.69 just to ship it to me here in Thailand. So we always get boned on postage. So total cost $15.17, and it'll probably take, I'm guessing, a week and a half to 2 weeks to get here, but it is really the right thing to do. Dedicated circuit to power my new goodies without putting a burden on the existing electronics in the bike. So I'm going to go ahead and buy that, get them started on getting it to me. Now the downside is I have to figure out what I'm going to do with my room so I can actually live here while it's coming. But that's my problem. Okay, I'll update you next time. Bye.